Hello everyone. In our previous class, we talked about image transformations and we have talked about few of the transformation techniques. In this class, we will continue with the other image transformation techniques. Right? So, in our previous class, we talked about DCT, Fourier transform, Walsh Hadamard transforms, and how did we calculate for the order 2 and order 4. So, in today's class, we'll talk about the Hart transformation technique. So, before we go for the hard transformation techniques, let me revise the coefficient matrices for the rest of the transformation techniques. So first, if we start with DCT, which is the discrete Fourier transform, if our coefficient matrix I am representing by a KLM1, then I can write it as alpha of u, alpha of m into alpha of n into cos of 2x plus 1 pi x. I can write it as 2kl plus 1 into pi m by 2n into cos 2l plus 1 pi n by 2n. So if we can write here the DCT equation as this form, which is dependent upon the cos functions. So that is why this is called as the discrete cosine function. So further, if we can write it as alpha of m into cos of 2x plus 1 pi m by 2n into alpha of n cos 2l plus 1 pi n by 2n, right? So we have said that a 2D function, a 2D coefficient matrix can be represented as the multiplication of two 1D functions. So DCT is separable. We called it as a separable functions, and it if we observe clearly, this 1D function and this 1D function are both very much, the function definition is similar. So that is why we even call it as a symmetric functions. Right? So next we talked about Walsh-Hadamard equation. We talked about Walsh-Hadamard equation, where the coefficient matrix is dependent upon the number of bits that are being used for representation of the intensity value. So if we write it as Mn, then we can write this as 1 by n into pi of I equal to 0 to small n minus 1 power bi of k into n minus 1 minus I of m. This is for Walsh, and similarly I equal to 0 to n minus 1 power bi of x into bn bi of n. Right? This is for Hadamard. Right? So the only difference between Walsh and Hadamard is the bit that we are referring here. Right? So if we observe more clearly, we can say that it is a separable as well as symmetric, as we have seen it for DCT. Right? So in today's videos, we will talk about the Hart transforms. Just like we have discussed about in our previous lectures, how to calculate, Hart transform cannot be directly calculated by a specified formula. There are multiple steps that we have to follow for calculating our Hart transform. So we'll see step by step. So first step that we have to do is the order of the coefficient matrix. So suppose we want to calculate the Hart transform of order 2. If a question says if we want to calculate for order 2, then we say that capital N is equal to 2. Right? Then we will calculate the value of small n, where the small n and the capital N are related by this. So when capital N is equal to 2, we can say that small n is equal to 1. Right? Next, the values of x, y, u, v values range from 0, 1, 2, 3, so on till n minus 1. Here, this xy representation is for spatial domain, UV is for the frequency domain. So when we are using hard transforms, we are converting our spatial domain image to a frequency domain. So in spatial domain, the image coefficients are represented by the XY image intensity values of X comma Y, whereas when we do the hard transform, they are represented by F of capital F U of V, right? So if X, Y, U, V values are ranging from 0 to capital N minus 1, right? So the next thing that we have to do is we have to calculate the variables P and Q. Okay, this P and Q values will define the number of rows that are existing in our hard transform and number of columns that are existing, right? So what are these values? If we have capital N and small n, here we assume that we say that P is ranging from 0 to small n minus 1. This is very important. It is not capital N minus 1. Here X, Y, U, V values are ranging from 0 to capital N minus 1, whereas P is ranging from 0 to N minus 1, which is small n minus 1, right? Now, if P is equal to 0, then Q is either 0 or 1. So if P is equal to 0, Q can take either 0 or 1. It cannot take any other values of Q. Now, if P is not equal to 0, that means this statement implies that if P is not equal to 0, then Q will belong to the range 1 to 2 power P. Okay, fine. Now, we have to determine the values of capital K and capital Z. So capital K will refer the number of rows that are existing in our hard transform. Z will refer the number of columns which are existing in our transform, right? So the K formula, the K number of rows can be represented by K is equal to 2 power P plus Q minus 1, and Z is ranging from 0 to capital N minus 1. So here another important thing is capital Z value is ranging from 0 to capital N minus 1. So if you observe clearly here, X, Y, U, V values range from 0 to capital N minus 1, right? P value will belong to small n minus 1. So this difference is we have to observe very clearly and remember it, right? So after calculating K and Z values, we have to calculate the coefficient. What is the coefficient values in our Haar matrix, right? So as we know that in a transform, if it is a matrix, then there are three things that we have to calculate. One is the size, number of rows and columns, which is represented by m cross n, and the elements, right? So these three things we have to find out. So if the size m cross n is defined from capital K and capital Z, now what are the element values that we will see now? So if K is equal to 0, then K or K0, h of 0 of Z is equal to 1 by square root of capital N irrespective of Z. So whether Z is equal to 0, 1, 2, so on till capital N minus 1, h of Z for K equal to 0 is equal to 1 by square root of N, right? Now, if K is not equal to 0, then what is the values? It is given by this equations. Now, if you observe clearly, we will calculate for each and every Z. So we check Z, it is falling in which range of the value. Say suppose Q is equal to 1, Z equal to 0, and P equal to 1, for example, then this equations will change to Q minus 1. So let's consider a small example where Q is equal to 1, P equal to 1, right? If we consider this example, the equations will go for Q minus 1 by 2 power P. So that will change to 0 to 2 power 1, right? And the next, this will change to 1 minus 0.5 by 2 power 1, right? this value will change to 1 by 2 power 1, right? So we check the value z is falling in which range and we calculate the coefficient from this values. So let's see an example how to calculate for the order n. Okay, so we call it as har 2 cross 2 kernel. If we want to calculate the har of 2 cross 2, it is referred that the order of the coefficient matrix is capital N equal to 2. Since capital N is equal to 2, we can say that small n equal to 1, right? So x, y, u, v values are ranging from 0 to capital N minus 1. So it replies that x, y, u, v will range from 0 and 1, right? Now we have to calculate the value of pq. Now here p will range from p is belonging to 0 to small n minus 1. So small n minus 1. This is very important as I said. So p will belong to 0 to small n value is 1. So minus 1, which implies that p can take only the value equal to 0. As I said, as the steps specify, if p equal to 0, then q can take 0 or 1. It can take either the value of 0 or 1. Now we have to determine the values of k and z. So we can write it in the form of a table. So write in the form of table where we specify the value of p, we specify the value of q, then we specify the value of k and z, right? So now when p is equal to 0, q can take either 0 or 1. So first case, if we consider 0, 0, then from the formula which is the given by k is equal to 2 power p plus q minus 1, as I discussed in our previous slide. So k is equal to 2 power p plus q minus 1. So this is given by, for the first case, 2 power p which is equal to 2 power 0 plus q is equal to 0 minus 1. So this will turn up to 0, right? Now when q is equal to 1, we say that when q is equal to 1, k can be given by k is equal to 2 power p which is 0 plus q is 1 minus 1. So this will turn up to 1, right? Irrespective of the value of k or p and q, z values will range from 0 to capital N minus 1, right? So in our previous slide we have seen that. So let me go back. So if you observe here, z is ranging from 0 to capital N minus 1. So I can say that irrespective of the value of p, q and k values, z is ranging from 0 to 1, which is given by 0, 1 to capital N minus 1. So this will give up to 0 to n minus 1, right? So if I write it in the form of a matrix, which is the Hart transform, I can represent my first row as k equal to 0, my second row as k equal to 1. Right? Now my first column I can represent as z equal to 0 and the second column as z equal to 1. Right? So that is why the k values and z values will represent the size of our kernel. Now we have to calculate the elements values. Right? We have to calculate the elements values. That I will try. That we will see now from this table. So write it again in the form of a table for our convenience. Right? Now when k is equal to 0, right? That means we are trying to find out the values of the coefficient matrix of the first row. So if we see that k is equal to 0, from our previous table, we can see that k is equal to 0 is obtained from p equal to 0, q is equal to 0, right? So let's write it in this here. Capital K, capital K, P and Q. So when capital K is equal to 0, P is equal to 0 and Q is equal to 0. To decide the value of Z, to calculate the value of K coefficient matrix, we have to calculate if the Z is falling in which range. But when K is equal to 0, irrespective value of z value, the coefficient matrix, the coefficient value is given by 1 by square root of capital N, right? That we have discussed in our previous slide. So capital N is equal to, here when we are trying to calculate for 2 cross 2, is 1 by square root of 2, right? So now, right, so this we have got it for the first row. So let me replace here. We got it as 1 by square root of 2, 1 by square root of 2, right? Now we have to calculate for k equal to 1, which means that we are trying to calculate for my first row, right? So when I'm trying to calculate k is equal to 1, we know that we obtained k equal to 1 from p is equal to 0 and q equal to 1, right? So let me calculate the values of q minus 1 by 2 per p, q minus 0.5 by 2 per p, q by 2 minus 2 per p, right? When q is equal to 1. So that will change to 1 minus 1 by 2 per p. So that will be 0, right? So 1 minus 0.5 by 2 per 0. This is 1 by 2 per 0. So that will be 0. Yes, 1 minus 1 by 2 per 0 will change to 0. 1 minus 0.5, this will give for 0.5. 1 by 1. So this is 1, right? Now, when when z equal to 0, right? So when z equal to 0, because we have two columns, z equal to 0 and z equal to 1. So when z equal to 0, so z equal to 0 is falling in which range? It is falling in this range, right? So if the coefficient value is falling between this range, then the coefficient is given by 1 by square root of n into 2 power p by 2, right? So that can be written as 1 by square root of 2 into 2 power 0 by 2, so which is equal to 1 by square root of 2, right? So I can write this as 1 by square root of 2. So how did I get this equation here? We got my equation as 1 by square root of n into 2 power p by 2. So when z equal to 0, or the z value is falling between the first sub-range 0 to 0.5, I can write my coefficient value as 1 by square root of n into 2 power p by 2. Now, let's come to when z equal to 1. It is falling in this range, right? So, when z equal to 1, it is falling in this range. So, the coefficient value, how is this given? It is given by 1 by square root of n into 2 power p by 2, right? And the sign value is minus 1. Right? The sign value is minus 1. So when we try to calculate the coefficient value, we get this as minus 1 by square root of 2. Right? So let me replace it here. So I get it as 1 by square root of 2, 1 by 1 by the square root of 2. So this is the Hart transform function for order n equal to 2. Right? So this is very easy to calculate, right? For order 2. Let me go and make it a little complex and calculate for order n equal to 4. So when capital N is equal to 4, which implies that small n is equal to 2, right? Since 2 power 2 is equal to 4, so small n is equal to 2. Now, x, y, u, v values are ranging from 0 to capital N minus 1, which implies that the values are 0 to 3, right? So, it can take the values 0, 1, 2, 3. Now, we have to calculate the values p and q. P belongs to the range 0 to small n minus 1, right? So, small n value is 2. So, p can take the value 0 to 1. So, p can take the values 0, 1. Now, there are two conditions here. So, when p is equal to 0 and p equal to 1. When p equal to 0, q can take the values 0 or 1. No other values. Now, when p is not equal to 0, or in this case, when p equal to 1, q range belongs to 1 to 2 power p, right? So, q belongs to 1 to 2 power 1. So q belongs to the range 1 to 2. So which implies q is equal to 1 and 2. Right? So when p is equal to 0, q value is equal to 0, q value is equal to 1. When p value is equal to 1, q value equal to 1, q value is equal to 2. Right? So this is the values of p and q. Now, based on this, we have to calculate the value of K and capital Z. So, like in our previous slide, how we have calculated in the form of table. Let me go here. Right? So, when P is equal to 0, Q is equal to 0, 1. Right? So, how K is given capital K? K is given by 2 power P plus Q minus 1. So, the same formula we are using it here. So, when P is equal to 0, Q is equal to 0, we get the K value as 0. Right? When P is equal to 0 and Q equal to 1, we get the value K value as 1. Now, Z value is ranging from 0 to 0. Z value is ranging from 0 to capital N minus 1. So there's a small mistake here. So Z value is ranging from 0, 1, 2 and 3. Right? Right. Now let's go for when P is equal to 1. When P equal to 1, Q value is either 1 or 2, like how we have written in our previous slide here. When P is equal to 0, Q is equal to 0 or 1. When P is equal to 1, Q is equal to 1 and 2. Right? So when P is equal to 1, Q value is either 1 or 2. Right? So when Q is equal to 1, we get the values as 2 power 1 plus K value as, right, 1 minus 1, which is equal to 2. When Q is equal to 2, we get the values as 2 power 1 plus 2 minus 1, which is given by 3. Right? So this is 2. So, right? So if you observe here, the K values are given by 0, 1, 2, 3 and Z values are given by 0, 1, 2, 3. So if I write my Hart transform of 4 order, then I can write as K is equal to 0 is the first row, K equal to 1 is the second row, K equal to 2 is the third row, K equal to 3 is my fourth row, as well as now Z equal to 1 first column, Z equal to 1, Z equal to 0 first column, Z equal to 1 is the second column, Z equal to 2 third column, Z equal to 3 column. Right? So the order is given by 4 cross 4. Right? That is why we say that order of 4 cross 4. Now we have to calculate the coefficients. So let's do in the form of table. Right? Now, when K is equal to 0, we got it from P equal to 0 to Q is equal to 0. So here when K is equal to 0, irrespective of the value of the Z values, we will consider here as 1 by square root of n. Right? So which is given by 1 by square root of 4. Right? So 1 by square root of 4. Now, the question comes here for when capital K is equal to 1. Right? When capital K is equal to 1, we have to calculate the range Q minus 1 by 2 per P, Q minus 0.5 by 2 per P, Q by 2 per P. Right? And then we'll check Z is falling in which range. Right? So, here, when P is equal to 0, Q is equal to 1. What is the value of Q minus 1 by 2 per P? That will change to 1 minus 1 by 2 per 0. So that is 0. Now here Q minus 0.5 by 2 per P, that is given by 1 minus 0.5 by 2 per 0. Right? So that will be given by 0.5. Right? That is given by 0.5. Now we have to talk about Q by 2 per P. Q by 2 per P is 1 by 2 per 0, which is equal to 1. Now, if we check the value of Z value 0, Z equal to 0, first case, Z equal to 0, that is falling in which range? It is falling in the first range. So, if it is falling in the first range, so what is the value, coefficient value? We have seen in the previous slide. Again, I'll write it here again. So, that is if it is falling in the first range, the coefficient value is given by 1 by square root of n into 2 power P by 2. If it is falling in the second range, second range, if it is falling in second range, I can write it as 1 by square root of n 2 power p by 2 with a negative sign, right? If it is not falling in either of these two conditions, I can take it as 0, right? So this is the coefficient matrix. So now when z equal to 0, it is falling in my first range. So coefficient value is given by 1 by square root of n into 2 per p by 2, which is given by 1 by square root of 4, right? Now when p z equal to 1, it is falling in my second range, so I can write it in the form of minus 1 by square root of 4 into 2 per p by 2, which is equal to 1. Now when z equal to 2, right, so it is falling in neither of these two conditions or in these two ranges, so the coefficient value is given by 0. When z equal to 3, same value, it is falling beyond the ranges, so when z equal to 0, the coefficient is given by 0, right? So next, since k values is 0, 1, 2, 3, we have to go on 1, 0 and 1s we have calculated. So for when k is equal to 2, we get the values of the ranges as 0, 0.25, 0.5. So when we check the range for the z values, we see that here it is falling in the first range. So here, if you observe, it is falling in the first range, right? So falling in the first range. So if it is falling in the first range, it is given by 1 by square root of n into 2 power p by 2, right? So which is given by 1 by square root of 4 into 2 power p is here is 1 by 2. So which I can write it as square root of 2 by 4, right? So this is equal to 1 by square root of 2. So 1, 2, 3, when z equal to 0, 1, 2, 3, it is falling beyond our ranges. So all the coefficient values are 0. So when k is equal to 3, the ranges we have got from here as p is equal to 1 for q equal to 2. So we got our ranges as this, as shown here. So when z equal to 0, it is falling outside the range. It is not falling in any of the range. So z equal to, the coefficient is 0. No, when z equal to 1, it is falling between the second range. So when it is falling in the second range, the coefficient is given by how? The coefficient is given by 1 by square root of n into 2 power p by 2 with the negative sign. So here 1 by square root of n, capital N is 4. So 2 power p here is 1 by 2, right? So this is equal to 1 by square root of, which is equal to 1 by square root of 2 with the negative sign. 0. When z equal to 2 and 3, it is falling beyond our range. So the values are 0, 0, right? So if I write my complete transform function, let me write my complete transform function. I get this as, if I write my first row, I get that as 1 by 4, 1 by square root of 4, 1 by square root of 4, 1 by square root of 4. So the first row is completely 1 by square root of 4, 1 by square root of 4, 1 by square root of 4, 1 by square root of 4. So in my second row, it is 1 by square root of 4. Second column is 1 minus 1 square root of 4, then 0, 0. So if I write it here, 1 by square root of 4 minus 1 square root of 4, 0, 0, right? So my third column is given by here 1 by square root of 2, right? And they all are 0, 0. And my fourth column is given by 0 minus 1 square root of 2, 0, 0, right? So this is my 4 cross 4 Haar transform function, right? So we have seen the Haar transform function for order 2 and column 4. And the most important things that we have to remember in Haar transforms are these steps, right? So these are the steps that we have gone through how to calculate my Haar transforms. So we have to remember our ranges, which are very important here. as is specified here. X, Y, U, V values ranges are from 0 to capital N minus 1. P values are ranging from 0 to small n minus 1. When P is equal to 0, Q value is either 0 or 1. If P is not equal to 0, then Q value is belonging to 1 to 2 power P. So this range values when Z is and K values are represented or calculated in the form of this equation. Next, the important thing in Hart transforms is this equation. So when when K is equal to 0, irrespective of the value of Z, the first row column is always given by 1 by square root of capital N. So 1 by square root of my order. So capital N is my order, right? So I can write it in this form. Now, when K is not equal to 0, then my coefficient values are given by this equation. So this equation should be remembered, and we have to calculate for each Z value and check if, and each combination of K, P, Q values, we have to check specific all the values of Z, in which value the Z is falling, in which range is it falling in the first range or my second range or no other range. So if it is falling in my first range, it can be given by 2 power P by 2. If it is falling in the second range, I calculate my coefficient value as 2 power minus 2 into 2 power P by 2, right? So this formula and the steps for Hart transformation techniques are very important, right? So thank you. And the best book that we can see here that is useful for calculating Hart transforms and the problems are this Gonzalez. So you can go through this book for further more information. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.